So we'll do a combined approach, sketch 1, f of x is equal to x minus 1 over x squared minus 1. 2, f of x is equal to 1 over x, and 3, f of x is equal to 2 minus the root of 3x minus 1, and then 4, f of x is equal to negative 3 plus the absolute value of 2x minus 3. So we have rational here, we have absolute rational, we have radical, and we have modulus on one page. Solution. Part 1, f of x is equal to x minus 1 over x squared minus 1. So how do we sketch this type of a function? This is a rational function. So you need 1 to find vertical asymptotes. Vertical asymptotes by equating the denominator x squared minus 1 to 0. This can be done also. You take x squared, you take 1 the other side, or we treat it as a difference of 2 squares, so that you can see something as well here. This is just x minus 1 multiplied by x plus 1 is equal to 0. This is only I've started, but we are waiting for you. So this is how you factorize this. And then x minus 1 equal to 0, or x plus 1 equal to 0. So x is equal to 1, or x is equal to negative 1. So we have these values. These are the values of x. Secondly, and we call these the vertical asymptotes. So on our sketch, which we'll put here, then the horizontal asymptote, y is equal to, because the numerator has a lower power as compared to the denominator, y is equal to 0 is the horizontal asymptote. So y is equal to 0. This one here. Remember here we only have 2 cases. They are equal, or the denominator is lower. Or the numerator is lower. Then we get back to our function. This function can be written as x minus 1 over the denominator. We have factorized it as x minus 1 multiplied by x plus 1. If we cancel on top and down, we will remain with 1 over x plus 1. This means that x minus 1 is the vertical asymptote. So negative 1 is the vertical asymptote. Negative 1. Then positive 1, this one here. It has been cancelled. So what we'll do is we'll solve for f of 1. We'll get 1 over 1 plus 1, which is 1 over 2. And then go here. This is 1. We're supposed to have asymptote here, but it has been cancelled. But we won't forget that we cannot use it. So open here. So we'll remove that special one. Because we'll never use 1. So there will be no value that will give us half. And then now we get the y-intercept there. To find the y-intercept for all functions, where there is x, you take 0. So you get 1 over 0 plus 1, which is 1. So the y-intercept is 1. So this comes down. Like that. It should never touch there. Then the other side, we pick n number that is less than -1, say -2. Then we'll get 1 over -2 plus 1, which is 1 over -1. This is -1. So we have -2 comma -1. So it is a function here. That's how you sketch such functions. I hope you understand. Or if there are questions, this is the time to ask before we go to question 2.
Is it possible for you to just run through our cut, like when you just started the question?
For every fraction, first you find the vertical asymptote by equating the denominator to 0. We equate it to 0. X minus 1, x plus 1 equal to 0. So we get x is equal to 1, x is equal to -1. These are vertical asymptotes. Horizontal asymptote, you compare the powers of the numerator and of the denominator. If the power of the denominator is higher than that of the numerator, then you get y is equal to 0. So then, looking at the denominator now, when it was factorized here, you realize that this part is also in the numerator. So when you write it there, this will cancel, will remain with 1 over x plus 1, like that. Then, because we have removed this x minus 1, which was giving us x is equal to 1, you pick this one, substitute in what has remained, you get half. So this half, so we have 1 comma half. This point is removed from the graph. If the graph wants to pass there, it will find an open hole there. It won't close because we'll never use this number 1 from the original question. If you place 1 here, you have an undefined thing. So to avoid that, you remove it in advance. Then you have your sketch, but you must know where it is touching the y-axis. So it's touching at 1. How do you know? You put x is equal to 0, you get 1. And then the other side, you have -1. You pick a number less than -1, say -2, so you can know whether it is above or below the horizontal asymptote. So I've picked -2 and you got -1. So it is below the horizontal asymptote like that. So, so this is how you get to the solution of this one.
Sorry, sir. I just want to know why have we excluded the value for x is equal to -1? Why have you not used it in the when plotting?
X is equal to 1. Which one? X is equal to -1 or x is equal to 1?
X is equal to -1.
Because if you put -1 here, you're going to get 1 over 0. 1 over 0 is unknown. If you use a calculator, it will tell you an error.
Okay, sir. I see.
Hello. You can get me now. Yes. So the other side, we go to 2.
Yes, I think I remember this.
2 f of x. F of x is equal to 1 over x, like this. First thing, we ignore the absolute value. We just get 1 over x. And then get the vertical asymptote. The vertical asymptote. You equate the denominator to 0. So it means x is equal to 0. When sketching, x is equal to 0, which is the y-axis. This is our vertical asymptote. Then our horizontal asymptote.
And then from there, there's the road coming from the main.
Horizontal asymptote.
Then how do I move there?
You check the powers. The power of the numerator is less than the power of the denominator. So y is equal to 0.
Or not following the road that is coming from.
Which is this one again. Like that.
Yes.
Then you now substitute on the right.
Then I tell
We pick 1. When we substitute now, we won't put in this one. We'll put in the original. So f of 1 is equal to
I'll let you know.
1 over 1, which is equal to 1, which is the same thing as 1. So 1, 1 above here. So we have a curve of this nature. Like this.
So is it that
What's the question?
so is it that we are picking 1 because 1 is greater than 0?
Yes. I'm also picking -1 because -1 is less than 0 and put in the original function. So get 1 over -1, which is equal to -1 in the absolute value, which comes out as 1. So again, we have the value here, meaning that this graph is going to go down like this. That is how this one is playing the role there. So let's see. So, unless there are questions there.
Sir,
Yes.
I have a question.
Mm-hmm.
My question is kind of similar to this one, but like looking at the rational functions we have in the tutorial sheet, where like on top there's just a number, then down we have maybe x squared minus Yeah, like that. How do you go about such rational functions, like sketching?
Like this one. We have a number on top and the variable.
Yeah,
down.
but on top there's only a number, there's no x.
Okay, maybe you mean something like almost what we're having here, only a number on top, no variable. So maybe you want it to have 2, x minus 1, x plus 3. Something like this.
Yes, like that.
So still vertical asymptote, x is equal to 1, x is equal to -3. So you have x is -3.
Excuse me, sir.
Yes.
Why is it -3 there? You just randomly pick numbers? Or it's coming from somewhere?
No. You equate the denominator to 0 and so for x. For vertical asymptotes, you equate the denominator to 0 and so for x. Then horizontal, you check the powers. So y is equal to 0. Then you sketch. So when x is bigger than 1, say x is 2, f of 2, 1 over 5, which is up here. When x is 0, in between there, we get 1 over -3. So down here. So we want to know is it is down, it can never cross there up. Then the other side, when x is -4, f of -4, that is 1 over -5 by -1, which is 1 over 5. The graph will be up here. The key thing for rational, you first find the vertical asymptote. Then you find the horizontal asymptote. Then you start picking numbers bigger than the vertical, less than the vertical, and less than the other vertical. Then you have your sketch.
Thank you, sir.
Wonderful. Question 3. F of x is equal to 2 minus the root of 3x plus 1 minus 1. Here we say you always start with the inside. So you start with 3x minus 1 and you get it to 0. So for x, 1 over 3. Then you get f. We said that it's not useful to get f and substitute this value. So you say the starting point is this number you get here, 1 over 3, comma, this number here, 2. If there's no number outside, then it will be comma 0. Then the y-intercept, f of 0, 2 minus the root of 3 by 0 minus 1. That is 2 minus root negative 1, which is not possible. So we have no y-intercept. So the starting point is 1 over 3, comma 2.
Is it the same if you want to find, is it the same to substitute 1 over 3 where this x in the original?
Yeah, so to get it 2, it's the same thing.
Right. Thank you.
Then, so we now have the starting point. We don't have the y-intercept. So let's check if there are x-intercepts by equating f of x to 0, implying that 2 minus 3x minus 1 is equal to 0. This is 2 is equal to 3x minus 1. You square. So get 4 is equal to 3x minus 1. Then we'll get 5 is equal to 3x divided by 3 divided by 3. So x is equal to 5 over 3. So we have a turning point. When we have the x-intercept, 5 over 3. So it means that it's coming down like this to touch here at 5 over 3. That's how we know the direction of the graph. When graphing this, you just take your time. Find the intercept, find a starting point, and then graph it.
Sir,
Hello.
I didn't get what you did here after when you substituted 0 in the equation to find the next point. Where the script.
So you said nothing was coming out of that.
Oh, so you jumped into the next one, the next coordinate.
We didn't jump. We got done there.
We got 0.
No, we got done here. We said since f of 0 is this number here, so we won't have. So no y-intercept.
Okay.
Then we check if we have the x-intercept now. X-intercept, and we have found it here.
Mhm.
Then we
Oh, okay.
sketch.
Okay. All right.
Hello.
Are we supposed, when we're done sketching, are we supposed to label the cave, this cave?
No, it's only cave, so there's no need of labeling.
All right. Unless the previous questions.
No need of labeling. No need of labeling.
All right. All right, sir.
Okay. Then -3 plus the absolute value of 2x minus 1. F of x is equal to -3 plus the absolute value of 2x. 2x minus 3. Okay. Similar, you start with what is inside there, 2x minus 3, and you get to 0. The value of x is 3 over 2. So the starting point will be we get the coefficients of the variable in there. The starting point will be 3 over 2, comma, -3. This number here. So once I do that, I prepare to sketch. So far, I have 3 over 2, comma, -3. Yeah. From there, we find the y-intercept. You get f of 0 minus 3 plus 2 by 0 minus 3. This is equal to -3 plus 0 minus 3, which is -3 plus -3, which is equal to -3 plus 3, which is equal to 0. So we get 0, 0 as the y-intercept. Then we can have the line. Straight line this side. Then the other one will have no choice but to go up like that. So this is 0. The good part is that we now have one of the intercepts known. The y-intercept has become also the x-intercept on this part. Then we need to find the remaining intercept by equating the whole thing to 0, -3 plus 2x minus 3 is equal to 0. This is for x-intercepts. Then you say the absolute value of 2x minus 3 is equal to 3. Then for this, you say this means that 2x minus 3 is equal to plus or minus 3. That's how you remove the absolute value. You put plus or minus, meaning that we have 2x minus 3 is equal to 3, or 2x minus 3 is equal to negative 3. So if I take this 3 to the other side, I'll get 2x is equal to 3 plus 3, which is 6, divide by 2. So we'll get x is equal to 3. So meaning that this number here is 3. You can solve this one. You take this other side. Suppose we didn't know, would have gotten 2x is equal to negative 3 plus 3. So 2x is equal to 0. So x is 0, which you already know. That's how you sketch the absolute, the radical, the rational radical. I mean the rational absolute. The remaining thing is the graph that I taught so nice that you cannot even talk about it. The quadratic sketch. That one, I emphasize that day that it's coming, and you should not complete the square and then determine the maximum minimum, and I'm sure you will know. And I'm repeating that it should be there. So this now serves to cater for all the graphs expected. You look at the coverage, quadratic graphs, absolute, radical, rational.
So how about inequalities?
Inequalities, you don't graph. Those are just equations.
Yes, how to solve them?
Don't worry. When you join now, we'll target equations. We'll solve the equations.
And
Yes.
how to define?
No problem. So you give me when it cuts here, you give me, this is 850, meaning 2050. So join at 2110. I need to have my sub. So 2110 we join. Is that okay?
Yes, sir.
Yeah, so that I should not
Yes, sir.
collapse.
Yes, sir.
I should not collapse on the podium, yeah. Completing the scale. Where do you find the courage, eh? All right, when we come back. Okay. Let's keep time. I'll stick to my time, I think. 20 minutes, I'll be done eating. The food is already. Let me just start.